Hi Mike, I know you recently did a teardown of your the thermal camera you have, and I thought you might be interested in seeing a slightly more recent, though still somewhat vintage, thermal camera. This is the one I happen to have. This is a, it's actually an infrared thermal security camera, so it actually mounts in like one of those big cans you see for, you know, the stereotypical thermal camera, stereotypical security cameras that then mount outside. This is slightly older. This is old enough that it's Indigo branded, which is the company that I believe FLIR bought, that now sells, you know, that is behind most of the technology that FLIR uses. I think this is, it's slightly vintage. I guess it's like 2004, 2005, maybe a little bit after that. But you can see it's got, you know, here's the Indigo logo. This one's slightly awkward because it's got a 50mm lens on it. With the very compact sensor size these have, it means that the field of view is incredibly narrow. So like if you want to take a picture, you know, like just a face shot, you have to be completely across the room. You know, so it's kind of awkward in normal use just because of the effective telephoto. It's 50mm f2.0. Like most of these, it's very touchy with regard to manual focus. You know, straight up normal manual focus. So anyways, I've taken it apart a little bit before, but let's just, I haven't ever gone inside the actual camera casing. You can kind of see that there's actually, like here's the thermal camera module, and it's actually got like this little, like PDA style connector on it. And then this is actually all just power supply and breakout. And so it takes, it's got a brick. It takes, as you might be able to read, it's 24 volts at 1.7 amps. One thing that's worth noting is these things get pretty damn warm, actually. I have a couple of these at my job that are more recent, and actually if you look at a thermal camera with a thermal camera, which is slightly amusing, it actually, the lens is actually quite warm. They definitely dissipate, you know, maybe 10 watts of heat, and because they're, you know, basically entirely convection cooled, they do get quite toasty. So this one, it you know, you've got your power. You know, you've got this is the video out. It's just composite output. It's got a serial interface for controlling. There's a fuse on here, which is kind of amusingly mounted because you can't actually take the fuse out. You know, good design there. There's a brick DC to DC on here, and I think I'll show you. You'll see in just a second. There's actually a bunch more brick style converters on the bottom of the board. Well, not brick style, you know, normal, just plain old discrete, and some interesting wire hacks. And then we'll get in the camera. The first thing is, the lens is quite easy to remove, well, somewhat. So the way it works is there's just like a little, you can see down here, there's just this little brass pin. And it's actually not screwed in there, it just sits in there, and that's actually what holds the lens in. So, or well, it's a stop for the focus. So if you pull that out, you can then completely unscrew the lens. Let's see if I can get these pliers in there. So you see it's just a little brass pin, and then the lens will now unfocus to the point where it just pulls out entirely, and you can actually see how that pin forms. There's a helix in here, and that pin is what allows you to focus. And you can look in there and you can see. So it's, I don't know, let's get some light on the subject. So there's the germanium window into the microbolometer array, and you can actually see, oops, if you look over in that corner, you can see the flat field calibration vane that snaps down to calibrate the, so it swivels down to calibrate the camera. And in fact, if I plug it in real quick, you should actually be able to see it cycle. 1 second. So if we look down in here, oh, there it goes, see? So that's how it's a little, it's slightly less obnoxious than the one you have, or at least slightly less loud. But it just pops in, and I've actually had these cameras where the flat field vane fails to cycle, they wear out after a while, or the solenoid failed. And what would actually happen, it was quite interesting, is that it would basically, whenever it would supposed to do the solenoid actuation, there's no actual positive confirmation that it moved. So what you would get would be suddenly the screen would go gray, and then if you moved, like, it would have a negative image of people standing in it if there was anyone standing in the frame. So let me just loosen these 4 bolts. Nuts. So it's amazing how much smaller they've gotten, and actually we have the place where I work has a number of much more recent ones that are even more compact. They're just, all the power supplies have been basically moved on to one single board, and they're literally about this big. We also have some that are that don't have this traditional interface that these do. They have a high-speed serial interface, or it's actually, or an Ethernet. It's done over Ethernet, and those are really interesting because they're. It's like internally the system is 14 bits, and then there's, with an absolute, and then what happens is the image data is down in like the lower 7 or 8 bits, and it moves where it is in the actual scale of it moves around as the temperature changes. So there's actually a bunch of DSP in here that is responsible for basically taking the min and the max and scaling the image to that. And then so if you get the actual raw 14-bit image out of it, you can kind of make out the picture in it, but it's barely there. And then so internally it's converted, or you can do some interesting measurement systems, with if you have the raw data. But it's kind of a pain in the ass because they use a high-speed serial system that's rather difficult to interface with. It takes special cards, like a special PCI card. So here on the bottom of this, we can kind of see, not much exciting. You've got a whole bunch of. These look like differential pairs, actually, now that I'm looking at it. This might actually have a high-speed serial interface, I'm not sure. But you've got, interesting stuff, like here's a little pi filter of some sort, I think. It's got a CLC in any event. These are some really big diodes, and here's a bridge rectifier. So I'm pretty sure, because this is intended for security camera applications, is that they can run off of AC. So it's got your input voltages, and then it goes through a bridge rectifier. And then you have this big electrolytic, which forms basically a filter, a line filter. So it actually says on here 14 to 30 volts AC, 12 to 36 volt DC. And then there's control, whatever that does. So serial number Indigo 250-0179-25-R100, whatever that means. Bunch of silicone goo. Camera's just held down. It looks like there's some sort of sticky paste tape, like silicone of some sort. So these are actually intended, you can actually see it's got an O-ring, so it's intended to fit in again, an outdoor security camera casing. And so what happens is this actually seals into like a cover plate, and then the thing's actually hermetic. I'm not sure what they do about the lenses, because again, they're germanium, and germanium's actually rather hygroscopic, so I think there's some thin film coatings on here to try and basically kind of seal it. It's also rather dusty, but that's kind of incidental. So as you can probably see, this uses this rather interesting connector, like a multi-pin connector. You can, there's a bunch of test points on here. This board is kind of interesting. There's actually, if you look on here, let's see if it focuses. There's actually one little bodge wire right there. It's rather cleanly done, so it doesn't worry me that much, but it's just interesting that went into production. You can kind of see these signal traces. They look kind of differential pairy, and they run right up into this connector here. But I'm not sure. You can kind of see there's presumably big heavy power stuff right here. And then this whole thing is very heavily shielded. And even though it's shielded, there's definitely some noise in the video. Anyways, let's disconnect. We actually, it's like I have some older ones, and I have this one, and the older ones are notice this one is older, and so we have some newer ones, and this one's noticeably noisier than some of the new ones. And I'm not sure if that's because they've refined the sensor or what they've changed, but they've definitely made some improvements in the system. So you can kind of look at the two side by side and definitely see that things have changed. And this is also held down with some double-sided tape. Oh wow, that's interesting. Look at that. There's a whole bunch of power resistors down here. I think they are actually heating the case. I wonder if this is intended to be installed in an outdoor environment where it might freeze. So they've got a whole bunch of big resistors. These are 101, these are 100 ohm resistors, and they all look to be in parallel. Yeah, they're all in parallel. So I would bet the reason these things run so hot is because they're heated. That's really interesting. I guess if you're having something that's intended to be installed in an environment where there's freezing cold weather, I guess that would become relevant. But I didn't actually know that. I wonder if that's what some of this DC to DC stuff is for. Because I mean, I wonder what's actually. Well, this actually looks to be like part of the video output stage, because you see here's the BNC output, and that runs into this C7. So I think this is like a video output buffer. I'm not sure what that is, aside from... This is definitely a multi-layer board, you know, because, you know, and then they've got the little copper squares here to just keep an even copper distribution. 0429, so that looks like this was week 29 of 04. So that, yeah, I was right, it was around 2004 vintage. Anyways, let's take a look at the camera. So here's the actual entire camera assembly, you know, without the lens. And the lens just pokes in there, and actually you can see again it's all very extensively sealed. There's O-rings on everything, and it's very nicely machined. It's got the Indigo logo, which is what that is. Built by Indigo Systems. Let's see, I need a slightly smaller hex wrench. Oh yeah. Let's see, there we are. Oops, let's try the other end. And that goes in there, and there. These may be metric, and I'm using standard SAE wrenches in them. And it seems to fit, but I'm not sure how well of a fit it is. I hope I don't mess up the heads of the bolts. It certainly does get stuck on there. So you can see there's you know, rev information. Rev 310. I wonder if that literally means they've been through 300 revisions. Big long serial number. Option 2227. Let's see if the case comes off. Oh yeah, it's on there rather snugly. Oh, hello. Look at that. Wow, that's some impressive construction. There are 1, 2, 3, 4, 5 circuit boards in here. And it's all one big flat flex rigid kind of, you know, complementary assembly. You can actually see the flex runs right into the center of the PC boards. Let's see if it focuses. There it goes. So you see this is one big flat flex assembly. I don't know if I'm going to take this any further apart, because it seems to be kind of... Oh wait, no, I could take it further apart. So this is interesting. Here's a really big mezzanine connector, which is presumably for other options. So you can actually, looking down in the side here, this is presumably thermal or mechanical. Oh, it just comes right off. So this is some sort of support. That's interesting. Look at that. There's a little thermal finger in there, which couples onto that pad there. So I guess this thing is, there's a lot of thermal. And then there's a whole boatload of these mezzanine connectors in there. So self-evidently this is the power supply board, you can tell from all of the tanks. Here's the output connector. There's a lot in here. That's really quite impressive. It's a beautifully engineered packaging. It's very, you can tell that they've been through a couple revs, just because they've gotten all of the, you know, it's just completely integrated. There's, you know, basically just connectors, everything plugs right in. You can see over here, this is going to be the lead for the flat field. Actually, there's interesting. There's a little green bodge wire right down in there, where they're tying one end of that capacitor to one of the screws. So that appears to be like a case ground. That's really interesting. See some of these ICs. So we have a Max 3221E and an ACT244. So that's just TTL logic, and that's a Max. That's an RS-232 transceiver, I think. 3221. I don't know. It's a Maxim device. There's an analog devices part that just says L and HA on it. Lord knows what that is. Handwritten serials. E07911. Let me think for a second. Let's try and take these two little tiny screws in here out. There's one. And here's the other. Actually, before I do that, I should probably go over here. Oops. Okay. So there is the back of the actual imaging sensor, and you can actually, there's actually another, how is that connected in there? I can't actually tell where it goes into the sensor. I don't know how the sensor is mounted. I'll probably take those screws out in a second. But so here we have a big Altera Apex FPGA with a rev number on it. Some of the more recent versions of these cameras we have, they're no longer using FPGAs. They just have one big custom ASIC. Oops. So here's this really amazing assembly. So that is a TI. Oops, it's out of focus. So this is a TI DSP. Come on, stop being difficult. There we go. It says 17V on it. I don't really want to peel that thermal pad out because it's being difficult. So this is it's a TI logo, and it says DSP on it. I don't know what the rest of it is. These are, let's see if I can get these to focus. They're definitely, it's presumably RAM. So you've got, yeah, here's more, and then here's the power supply board. There's lots of inductors and all that sort of stuff, lots of capacitors and inductors on both sides. So you've got power supply, signal processing, data processing, some sort of really big FPGA, which is presumably custom, and then over here you've got a big 809241. So that's presumably the analog front end. And then there's some various linear tech parts around there. I bet a lot of the stuff is bias voltages for the sensor. Little inductors. Oh wow, look at that bodge. That's amazing. So let's see if we can look at that. There's a very small, like an 0402 capacitor dead bugged on top of this linear tech device right here. And it's just hanging on the leads, but I guess the device is so lightweight that they can get away with it. That's really interesting. So I mean, it's definitely got some slight after the fact repairs, but they're all very, very beautifully done. So here's the motherboard. So this is just, oops, you gonna focus already? There it goes. So this is just some big mezzanine connectors. Looks like a little bit of filtering of some sort. And then whatever this is on this side, the RS-232 transceiver and some of the logic, and then this is a mezzanine connector that goes to another application apparently, because it doesn't go anywhere in the case. And then there's some unstuffed stuff over there. From the look of it, big power traces. This is probably a DC to DC of some sort that's not there. There's a little fuse. Bunch of logic buffers, just 5-pin devices. Anyways, let's see what's under here. We have some of just the raw sensors at my job, and they're quite interesting looking. They're just You know, they just look like little gold cans with a window on one side and a bunch of pins coming out the other. They have remarkably few pins. It's like the sensors we were looking at, which are, these are a 320 by 240 microbolometer array. They've only got about 8 pins, 10 pins. And it actually mounts like a SIP package, which is really interesting. Let's see if this disconnects at all. Oh, yep, there's a connector under there, I can feel it. Oh wow, this is a much earlier one. So there's the back of the sensor. And then you can see mechanical mounting, and this one has a lot of pins. So there's the other end. So this just has a REF192 from Analog Devices, and another one of those parts that are marked with LHA, whatever the devil that is. So that's all the processing right there. I'll just put that down. Let's take this off. Let's see if we can get into the sensor. Well, I'd rather do it the other way. So this has, I think the lens mount comes off, presumably with these. So I think you can mount different optics on the one package, basically just by replacing the the actual front cover of the mounting. I don't know how far I want to take this apart, just because I'm not sure where the vacuum sealing pit for the sensor is. I mean, I think they've got them pretty nailed down so that they're pretty tight, but I bet you could break the cover window if you put any effort into it. Oops. One more to go. Window is very reflective. Let's see, there we go. So wow, look at that. That's interesting. The sensor's changed quite a bit. So there's the sensor. The ones I've seen have a rectangular window, which is rather interesting. This one has a circular window. So you can see the sensor, and then here's the flat field calibration vane. And it looks like, that's rather interesting. It looks kind of like a motor. Wow, yeah, look there. So there's the if I flip this down, let's see. There's the sealing pip, which is really interesting, because they've eliminated that or made it a lot less noticeable on their more recent models. This is either a rotary. It actually, I think it's geared. I think this is actually, they're using a DC motor, which is rather interesting. You can kind of see this is just, wow, it actually looks like it touches the surface of the sensor slightly. I think maybe this veining has been a little bent. This, I got this camera used. I didn't pay anything for it, so I wasn't complaining, but it might have been slightly abused in a past life. I don't think I'm going to unmount the sensor. I don't really see any reason to, and it might misalign some of the optics. But anyway, so there's the actual, that's what they've gotten the sensor down to, and then the vane just pops in, and there's your flat field. Oops. Let me just tighten down there. Just goes right back together. So they actually make versions of this which are Ethernet interfaced, which is rather interesting. And this is, I guess they're used for like industrial vision applications. So basically they just stick them all on the network and handle it. It's gigabit Ethernet if I remember correctly. It's been a while since I played with them. I don't have a lot of uses for this, mostly because it takes a lot of, it's kind of clunky. I'll probably try and turn it into something more portable at some point, but I'd like to buy a better lens, just because it's kind of unusable with the current lens assembly I have, just by virtue of the fact that there's just it's too zoomed in. Like you have to use it from across the room if you want to do anything meaningful. Oh. So that goes in there. Let's see, and then there are 3 little screws which hold that down. I might like swap the lens on this with one of the ones from my job, because we work on telescopes. So I can see the places where I work actually having a use for the slightly excessive zoom, whereas I really don't. And you know, in all likelihood, nobody will ever notice, because we actually have a box of these sitting on a shelf that it's just going to waste, really. It's kind of tragic, but you know. Those connect up like that. Big multi-pin connectors. I think Hyros makes these, if I remember correctly. Just make sure they're all properly seated. That sits down like that. Lots of high-speed logic in here, you know, and really interesting, really elegant packaging, actually. You know, a few minor bodges, but they're all rather nicely implemented. You can kind of see the, there it is, you can see the little ground lead running to that pad there. You know, apparently they needed to ground the case more aggressively. And then there's that other bodge lead with that little tiny capacitor. Those tighten down. I don't get them snug, but not too snug. Oops. Get in there, you. So then that plugs in there. That's interesting. It looks like there's two. The flat field calibration plugs into here, but I wonder what that one's for. I wonder if this has two flat field options. And there's that unused mezzanine connector. So then we take this, which is some sort of thermal management of some sort. And that kind of just pushes in there and retains the other end of the boards just by virtue of the fact that they poke through those little holes, little tabs. I wonder how much effect that really has, because you can see the little copper finger just slightly rests. Let's see, it just lightly rests on that thermal pad. I can't imagine it does much. But, you know, and on top of that, it's not even on the entire surface of the chip. There's just that little kind of the corner. And whatever. Kind of see, it's actually interesting. It looks like these are very many layers of flex. There's probably two, maybe, I think there are 4 layers, because I see shield on that layer and I don't see anything here. Which must mean that there are interior layers. I know they can make multi-layer flex, but they're expensive as hell. But then, you know, considering how much these cost. I've actually talked to some of the people who are the original, you know, some of the people who work for FLIR. And apparently they've gotten the cost down remarkably far. Apparently the actual production costs for these things are, at least the more recent versions, are actually in the range of $500. But they spent, you know, like many millions of dollars, you know, NRE on designing them. So they charge $10K just because they need to recoup their NREs for the engineering that went into designing them. So hopefully and theoretically within the next, you know, few years, once they've recouped the majority of their engineering costs, the price will come down to something more accessible. They're also getting the resolution up. They now have, I mean, I know they now have 640 by 480 ones. Pretty big on the market. I've also seen some rather unusual stuff. The camera's doing some weird logo on the screen. We'll see if it craps itself. So, you know, the resolution's getting better and the price should come down pretty dramatically, because apparently the production costs are fairly low. But FLIR apparently has a bunch of patents on everything related to the FLIR, the company they've purchased, have a bunch of patents on everything related to the microbolometer array production, and therefore they largely have a monopoly, so they can just charge whatever the market will bear. And because they're largely targeting big corporations which need these, you know, they can get away with, you know, ridiculously over expensive, you know, very high prices, simply because the people who need them don't care, and they don't really have any interest in hobbyists. So which is kind of a tragedy, because I think, you know, getting these into the hands of hobbyists would produce some really fascinating art. Because I bet, you know, you give a bunch of these to a bunch of artists and you get some really interesting projects.